Chapter 3.1 Measures of Central Tendency. In this lesson, you're going to learn to determine the arithmetic mean of a variable, the median, explain what it means for a statistic to be resistant, and be able to find the mode. So what are the three characteristics that we should consider when we look at a distribution of data? So we plotted those histograms in Chapter 2. So in Chapter 2 we started on one of these characteristics, and that's the shape. Again, we can have uniform, bell-shaped, skewed left, or skewed right. And then in this unit, we're going to learn center and spread. Central tendency, this just means the center. So 3.1, we're going to learn this characteristic. So let's start with the mean of a variable. How do you calculate that? You add all the values together and then divide by the number of values. For your calculator command sheet, you're going to use number 1. So let me pull this up. So if you want to find the mean, you're going to use this number 1. It also helps you find the standard deviation, variance, min, max, and quartiles. So let's just write number 1 here so you can refer back. And then we have some symbols. Mu, which is a U with a tail in front, represents the population mean. And the way you pronounce that is mu, mu. And then we have X bar. This represents the sample mean. The table below shows the first exam scores of 10 students enrolled in introductory statistics. Compute the population mean mu. So I'd like you to do this by hand. So mu. What you're going to do is add them all up together. When you do that, you get 790. And then up above it said divide by the number of values. There are 10 values. So the mean should be 79. So now let's use our calculator sheet and follow this list to put it in our calculator. So the first step is input data in list 1. So you go to stat and then edit. So we're right here. Next step. Sorry, we're still on A. We need to input the data. So let's type in the data. One. Okay. If you go up to the last one, that means the last number is the 10th number, and we had 10 in there, so that is correct. Part B, stat calc 1 var stats, so enter. Okay, notice my calculator on the screen is not a C Silver or a CE edition. So I'm going to do this edition just because the library rents these out. That way you can see it done here. if you have this addition, this is going to be set up nice and easy for you. You're just going to follow the steps exactly on this sheet. So on here, we're going to either hit enter or you're going to put second list 1 because that's where our data is at. If it was in list 2, you would have done list 2. Hit enter. This is our mean. S of x means our sample standard deviation, which you'll learn later on. And then sigma x is our population standard deviation. Also notice there's a down arrow. You can scroll down. You can see the min, Q1, median, Q3, and max. I'll get to these later, but I just want you to be aware that that's what's on under one var stats. So let's go back, compute the mean. Okay, notice the calculator only has x bar. The calculator does not know if it's sample or population, so it's always going to assume it's a sample. So you're going to have to decide, is it population or is it a sample? So then you'll have to determine what symbol to use. So you can see 79 matches up with what we found. Now, find a simple random sample of n equaling 3 students. So I will just do the simple random sample. If you did this, you would end up with a different number. So it's going to be between 1 and 10, because we have 10 is our population. So 10, 2, and 6. We don't want to repeat, obviously. So our simple random is 10, 2, and 6. So 10, 2, and 6. Compute the sample mean of those 3. So let's just do this with my hand. When you add the numerator, you get 233 divided by 3, which is equal to 77.67. So our sample mean is pretty close to the population. So does this sample mean over or underestimate the population? Well, this is under that or less than, so you can say underestimates. Just as we continue with this, just think of the center as the mean as the center of gravity. So the histogram balances when supported at the average. You can also think of this as the fulcrum point. So in this case, the median for this skewed left data would be the fulcrum point, or the center of gravity.